Hey guys, today we're going to be doing this AP Physics 1 momentum problem. I'm just going to get straight into it. So, the question says, a person of mass 60 kilograms, alright, so a person weighs 60 kilograms, sliding down along level ice at a speed of 3 meters per second. This person that is 60 kilograms, here's our 60 kilogram person. I'm going to actually draw them like this so I can draw. Okay, they're 60 kilograms, is sliding down along level ice at 3 meters per second. And they collide with a second person who is initially at rest. The second person is initially at rest. So I'm kind of already getting an idea of what we're going to do here, but let's read the whole problem, which is right here. And their V equals 0. Assume that friction is negligible, okay, which means that the total momentum is going to be conserved. If the two people hold on to each other and their common final speed after collision is 2 meters per second, what is the mass of the second person? So this is X. And after they collide together, they have a speed of 2 meters per second. Okay, so one, I can say that momentum is going to be conserved. A couple things give it away, but it's especially that we're neglecting friction and you're on level ice. So the law of conservation of momentum states that if two bodies collide in a closed system, which is right here, we are in a closed system right here, we're ignoring friction or air resistance, whatever it may be, and we have mass conserved. The total momentum before the collision, so that's potential energy. Your initial momentum is going to equal your final momentum. And that's the total momentum, final momentum, they're interchangeably used. So with this equation, we can go ahead and solve. So this momentum is P equals mv. So initial is going to be m1v1 for the first person plus m2v2, these are all the initials, is equal to m1v1 final. Well, it would be actually m1 plus m2 v final, because they're going to hold on to each other and have a common final speed, which means you can factor out the velocity because they're equal. They're the same. So let's go ahead and solve for it. Our mass we're solving for mass. So our mass of the first person is 60 times their velocity, which is 3, plus the mass of our second person, which we don't know, times their velocity, and their initial velocity is actually 0, so this term will cancel out, is equal to the mass of the first person, which is 60, plus the mass of this person, who we don't know, times our final velocity, which we just said is 2 meters per second. So now we just really have to do like an algebra problem. So 60 times 3 is 180, which is equal to 60 plus x times 2. You're going to distribute the 2. You'll get that 180 equals 120 plus 2x. You subtract 120 to give you 60 equals 2x, which will further tell you that 30 is equal to x. So the mass of the second person is 30, which is true.